Hi, in the first part of the video, we have solved some problems relating to chain rule. Now we will see some more problems in this particular lecture. The question is, a rope makes 140 rounds of the circumference of a cylinder whose radius of the base is 14 centimeter. How many times can it go round a cylinder with radius 20 centimeter? That means we have two cylinders. Question is easy to, we have two cylinders. One cylinder is with the radius 14 centimeter, base radius 14 centimeter. We have another cylinder with the base radius 20 centimeter. Okay. By using a rope, we are tying around this cylinder. By using a rope, we are tying around this cylinder. By using this particular rope, we are able to make 140 rounds. We are able to make 140 rounds. Okay, fine. Then, if we are using the same rope in order to rope over the cylinder whose radius is 20 centimeter, we have to find out how many such rounds can be possible around a cylinder whose base radius is 20. Fine. So, we can easily calculate the length of the rope. The length of the rope equal to the circumference covered by the rope in one circle or in one rotation into the total number of rounds. Correct? So, the number of round is 140 into what is the base radius for the first cylinder? That is 14 centimeter. Therefore, circumference equal to 2 pi into 14 centimeter. Fine, because circumference equal to 2 pi r. We are using the same rope in order to rope over a cylinder whose base radius is 20. That means length remains constant, 140 into 2 pi into 40. Length remains constant, which is equal to the number of rounds which can make into the circumference of the second cylinder, equal to 2 pi into 20. 2 pi cancels. Fine. 140 and 720 cancel, you will get 7. Okay, therefore x equal to 14 into 7, 10 into 4, 10 into 7 is 70, 70 plus 28 equal to 98. So the answer is going to be 98 rounds. So this is an easy question. Hope it's clear. Next one. If 5 engines consume 6 metric ton of coal when each is running for 9 hours per day, how much coal will be needed for 8 engines, each running 10 hours per day? It is being given that 3 engines of the former type consumes as much as 4 engines of the later type. So we have two types of engines, that is engine type 1 and engine type 2. The amount of energy or the amount of coal which is consumed by the first engine, that means 3E1, is equal to 4 engines are of the later type, that is equal to 4E2. That means the consuming power of the both engines are not same. So we cannot equate the work done by the both engines simultaneously. So we have to interchange the factors. Okay, fine. Hope that much is clear. So from the first part, 5 engines consumes 6 metric ton of coal when each is running for 9 hours per day, means 6 metric ton of coal is the amount of coal which is consumed by the engine type 1, engine type first engine type. Okay, first engine type consumes 6 metric ton of coal. That means this 6 metric ton of coal is nothing but the work done by the first engine. Hope it's clear. That means we know that work done equal to M1 D1 H1. Here they have not given the number of days. Here hour is given. Instead of man, here we have engine. So what we can write? 6 equal to 5. Which type of engine? First type of engine, 5E1 into 9. Hope it's clear. Okay, fine. Then the second type, what it is given? The second type, we can clear that. We have 8 engines. We have 8 engines. It is running for 10 hours per day. It is running for 10 hours per day. Running for 10 hours per day. We have 8 engines of the second type. So what is the work done there? Here work done be W1. Here the work done W2 is equal to 8 engines of the second type. 8 engines of the second type working for 10 hours per day. Working for 10 hours per day. So from these two equations, we can write it as 5E1 into 9 divided by 6 equal to 1. 8E2 into 10 divided by W2 equal to 1. We can equate the both. 5E1 into 9 divided by 6 equal to 8E2 into 10 divided by W2. Fine. We can cancel this one, this one. Here you will 9 and 6, you will get 3 here. Here you will get a 2 here. Fine. No issues. Then we know that 3E1 equal to 4E2. That means E1 equal to 4 by 3E2. Substitute over here, what you will get? 5 into 4 by 3 E1, sorry, 4 by 3 E2 into 3 divided by 2 equal to 8 E2 into 10 divided by W2. 3 cancelled up. 2 and 4 cancel up, above you will get a 2. 5 into 2, 10. 10 cancel. E2 cancel. Therefore, W2 equal to 8. So, how much metric ton of coal will be consumed? That will be 8 metric ton of coal. What is the need of this much amount of steps? We can skip. We can solve this particular question in one single step itself. How? Fundamentally, we have an equation that is M1 D1 H1 divided by A1 equal to M2 D2 H2 divided by A2. Here, instead of M1, we have engine. Instead of amount of work done, we have amount of coal consumed. Okay. Only the thing we have to equate is 3E1 equal to 4E2 or E1 equal to 4 by 3E2. Directly substitute the things. What you will get? 5E1, days is not given, so no need to mention, divided by 9 into 9 divided by 6 equal to, on the second case, 8E2 into 10 divided by W2. We don't know how much amount of coal is consumed. So we can replace E1 by 5 into 4 by 3, E2 into 9 divided by 6 equal to 8E2 into 10 divided by W2. 5 into 4 is 20. 20 divided by 10. Here you will get a 2. 3 and 9 cancel. Here you will get a 3. 3 into 2, 6. 6 cancel. Therefore, E2 cancel. Therefore, W2 equal to 8. You can solve this particular question in one step. But when I am teaching, I have to give all the steps. That's only the reason I have given all these steps. But when you have expertise in solving the problems, you can solve these particular questions in 10 seconds, 20 seconds itself. First time you may be taking 1 minute. Later on the later stage, you can finish this particular question in 10 to 20 seconds. Next question. A contractor employed 30 men to do a piece of work in 38 days. After 25 days, he employed 5 men more. The work was finished 1 day earlier. How many days he would have been behind if he had not employed additional men? That means his piece of work has to be carried out by 30 men by 38 days. That means his work is 30 into 38 man days. Fine, this is his work. For the first 25 days, we have for the first 25 days, there is 30 men were working. There were 30 men were working. Okay, fine. 30 men were working. After that, he has added 5 more men. That means number of men become 30. The work was finished 1 day earlier. The work was finished 1 day earlier. How many days he would have been behind if he had not employed additional man? If there is no additional man, if there is no additional man, how many, what I can say, like how many additional days may be taken by this particular contractor to complete this particular work? I just made a small mistake because we cannot write this particular thing. So what happened? What has happened now? He has employed the workers for 38 days. For the first 25 days, there were 30 men were working. So the remaining, we have how many men? Sorry, remaining we have 13 days. When he employed 5 more men after 25 days, he is able to finish his particular work 1 day prior to the scheduled time. That means he has finished his work in 37 days. That means for the remaining 12 days, there were 35 workers. That means his total work was 25 into 30 plus 12 into 35. Hope it's clear. 25 into 30 plus 12 into 30, 12 into 35. That means 25 into 30 is 750 plus 35 into 12. 35 into 10 is 350. 350 plus 70 equal to 420. So on addition, what you will get? 0, 7, 1170. 1170 man days is the total work. If he has done this particular work by using only with 30 men, if he is tried to finish this particular work by using 30 men alone, how many days does it take? How we can calculate? The work is 1170 man days equal to number of men 30 into number of days, let it be x. Therefore, x equal to 117 divided by 30, cancelled up. 117 divided by 3. 120 divided by 3 is 40. That means 117 divided by 3 is going to be 39. So he will take 39 days. What was the scheduled time? 38 days. Now he had taken 39 days. So how much extra day taken? 1 day. So when I am reading this particular question for the first time, there were a confusion in my mind. Later, I read the question one more time. I came to understand that I just made a small mistake. So when you're reading the question, be very, very careful and be cautious about the questions. Okay, hope it's clear. We cannot take 30 men in 30 days because like if the work is completed in 38 days by 30 men, then the work can be calculated as 30 into 38. But this is only scheduled thing. We are not finishing it up. Okay, hope it's clear the sense. Next question. If 3 men or 6 boys can do a piece of work in 10 days, working for 7 hours per day, how many days will it take to complete a work twice as large with 6 men and 2 boys working together for 8 hours per day? This question is moreover a part of work and time. In that particular area, we will see lot of questions related to this particular topic. But For the initial stage, for the initial understanding, we will try to solve only one question. Okay. Here they have given that 3 men or 6 boys can do a piece of work in 10 days, working for 7 hours per day. That means men and boys are working for same number of days and same number of hours. That means the number of men is equal to number of boys. That means the efficiency of 3 men is equal to efficiency of 6 boys. That means 1 man is equal to 2 boys. Hope it's clear. 1 man equal to 2 boys. If they have worked for different number of days and different number of hours, we cannot equate like this. At that time, we have to multiply number of men into number of days into number of workers equal to number of boys into number of days into number of number of hours. Okay, here we have the mistake. How many days will it take to complete a work twice as large with 3 men and 2 boys are working together? We have 6 men and 2 boys are working together. They are working for 8 hours per day. They are working for 8 hours per day. So we can simply calculate the amount of work here. The amount of work W1 equal to, you can take either in the case of men or in the case of boys. It's according to your convenience. I'm taking for men. That is 3 men working for 10 hours per day. Sorry, 10 days for 7 hours per day. That is equal to 210 man days. We need to calculate how many days will it be take to complete a work which is twice as large. That twice the work. That means W2 means 420 man days of work. This 420 man days of work is carried out by 6 men and 2 boys. That means 6 men and 2 boys are working together for 8 hours per day, such that how many days is required to finish a work which is equal to 420 man days. Since we expressed our term in terms of man days, we have to replace the work done by boys into the main case. We know that 2 boys equal to 1 man. So we can write it as 6 men plus 2 boys equal to 7 men into 8 into x. Okay, equal to 420. Okay. We know that 7 into 6 is 42. So this is 60. Fine. Therefore, x is equal to 60 divided by 8. What is 60 divided by 8? Did any mistake? Eight into 7, that is 56. That is 40. 40 is point. It is 7.5. It is 7.5 days. I just got stuck there when I'm dividing 60 by 8. The answer is 7.5 days. Hope it's clear. It's a very simple question. Here only the point we have to be very careful is that we have to do a work which is twice as large as of the initial one. So be careful about that. Then also be careful about this case. Check all the cases whether they have given same or different. Okay, that's only the thing you have to be careful. Next question. If 70 laborers can dig a ditch 26-meter long in 18 days, working for 8 hours per day, how many more laborers should be engaged to dig a similar ditch 39-meter long in 6 days, each labor working for 9 hours per day? Okay, I just made extra one statement here. Let me clear it up. Okay. The question end here. Sorry. So the 17 laborers are working, can dig a ditch of 26-meter long in 18 days, working for 8 hours per day. Okay. So we can directly write 17 into working for 18 days, 8 hours per day. They ditch a work of 26-meter long. How many more laborers should be engaged to dig a similar ditch which is 39-meter long in 6 days, working for 9 hours? We don't know the number of workers. We can simplify it. 18, 6, you will get a 3 here. 3, 9, you will get a 3 here. Then 26 and 39. So division by 13, here you will get a 2, here you will get a 3, this 3 and this 3 cancel. 2 and 8 cancel, here you will get a 4. So we have 17 into 4. What is 17 into 4? 10 into 4, 40, 40 plus 28, that is 68. You will be confused why this guy is doing the problems in the one step. You can solve it like this. Have another method. What is the work done in the first case? First case is 17 laborers are working for 8 days, working 18 days, working 8 hours per day. What they made? They made a 26-meter long ditch. That means the work is equal to 26 meter. In the second case, we don't know the number of workers. The number of workers be X into they are working for 6 days. They are working for 9 hours per day. They have to make a ditch which is 39-meter long. So their work is 39 meter. Then take the right hand side become 1. That means divided by, get the same. What we did was M1 D1 H1 divided by A1 equal to M2 D2 H2 divided by A2. Number of men, number of days, number of hours, what amount of work has to be done. Hope it's clear. Is that fine? So we have seen lot of problems relating to chain and rule. In this particular video, we have seen 5 problems. 5 problems are of different types. Hope you enjoyed. If you're feeling any doubt, do let me know in the comment section. I will answer to that. So for the time being, we are uploading 2 videos regarding to chain rule. By this particular video, we are just stopping chain rule. We will go to the next topic. In future time, we will add more videos related to chain rule also. If there is any update or if I have to solve more questions or something like that, it all depends upon how you are responding to it. Thank you. Thank you for attending this particular lecture. Thank you.